Welcome back to the CAT DLR 100 series. We'll be looking at case 3. This is a very interesting CAT case, right? Now, before we start with it, we're going to change the pattern slightly. In the sense, let me give you reasons as to, whether to choose this case, why you should choose this case, and what you should be careful about while working with cases like this, right? Otherwise, it's just a question of, solving all these cases. Now, why should one choose a case like this? Now, what do we see over here? We have some simple numbers. Is it a big case? No, not a very big case. We have a few conditions, and then we have an example given over here, and then followed by certain questions. How many individuals in this layout can be reached by just one individual? There's no cannot be determined. Looks like it's a fully solvable case. So therefore, pick it because it's a short case, simple numbers, and questions suggest that it is fully solvable. Now, what should you be careful about while solving a case like this? Right? These are the things. You've got to slowly read and properly understand the conditions. It's not a standard case, right? You're completing your VARC section, you're coming to this. You got to go slow. You can't be reading these fast. Every sentence, every part of a sentence can have a certain condition. You've got to be very careful. You've got to reproduce this entire table, right, without making mistakes. It involves looking up at the screen and then looking into your notebook, right? You've got to be very careful while doing it. Don't look at the timer and get stressed. You'll see a timer over there, 38 minutes and 47 seconds, and you might write 7 instead of 6. Don't do all that. Just focus only on this and correctly write them down. And if required, you can double check also a little, right? Double check and make sure that it's correct, because accuracy is very, very important. What is the point in spending 12 minutes or 10 minutes and getting 3 mistakes rather than spending 14 minutes and getting everything correct, right? Little extra time to double check is perfectly fine if your accuracy is going to be full. Having said that, let's start with this case, right? So what do we have over here? In a square layout of size 5 meter into 5 meter, fine, something like this, 25 equal size platforms of different heights are built. The heights of individual platforms are as shown below. Now, what do I understand? These are all going to be my heights. I'm just given a two-dimensional square. Each of these represent a height. It's a platform. And what else is given? Individuals, all of same height, are seated on these platforms. You also have people sitting on these platforms. We say an individual A can reach B if all of these conditions are met. A and B are in the same row or column. A is at a lower height than B. If there is or are any individuals between A and B, such individuals must be at a height lower than that of A. Now, some of you will be able to quickly understand this and also move to this particular part, right, which is an example given over here. But for some of you, it might be like, hey, let me visualize a bit, right? So how do we visualize? Draw something like this, right? I've just drawn roughly the heights for the first row, right? The first row over here. So this is 6 meters, right? This is 1, this is 2, then you have a 4 over here and a 3. Now, what does this say, right? All the 3 conditions have to be met for an individual A to be able to reach B. A can reach B when A and B are in the same row or column. I've written down the same row, right? Same row or column is required, okay? A is at a lower height than B, right? So if this is A, can I reach B? Yes, that's fine. That's done. A can reach B over here. It happens. Okay, great. Now, A is at a lower height than B. Yeah, that's done. Yeah, I just did that. If there is or are any individual between A and B, such individual must be at a height lower than that of A. So that means if A is sitting here, B is sitting over here, can A reach B? Is in the same row? Yes. A is at a lower height than B. Great. Second condition is met. The third condition, if there is somebody between them, that person's height should be lower than A. Yes. That means this person should not be obstructing A. Right? So if A is over here, yes, can meet B. Right? So let's just name these people as A1, A2, A3, and A4. Right? 1, 2, 3, 4. I'm just, let's not confuse ourselves. So let's write 4 over here and 3, right? I'm just writing the height numbers. Can A1 reach B? Yes. Can A2 reach B? Yes, because you have somebody in between, but it is at a height lower. It's not obstructing the view. Can A4 reach B? Yes, because two people are there, but both are lower than A4. A4 can clearly see B, and A4 is lower than B. Now what about A3? Can A3 view B? No, because 4, right? Height of 4 is obstructing this view. Between A3 and B, you have one person whose height is more than A3. So therefore, this person can't reach B. B can be reached by 3 people over here. Now, what about the other way around? Can B reach these people? No, B can't. B is taller, right? For you to reach, you've got to be at a lower height. B cannot reach anybody. You can reach a person by only looking up. You can't look down, right? Visualize that way. And if this part is clear, you just have to reproduce the table and start filling it up. Let's look at the example given over here to further understand this, right? So this table over here is replicated. I've written the numbers over here on the bottom left. We probably have to find out, how many people can reach them, and we'll fill it up over here itself, right? So what's given over here? Thus in the table given above, okay, that is here, consider the individual seated at height 8 on the third row. 1, 2, 3, third row, and second column, 1, 2. So this person. Now this person can be reached by 4 individuals. Now let's try to find the 4 first. Can 5 reach 8? Yes. Can 1 reach 8 over here? No. 5 is obstructing, right? So I'm not going to put a tick there. I need to look at the same column or same row, right? So only these 8 people over here. Now 9 over here can't look down. So not happening, not happening. 7 over here is blocked by 9, so can't reach 8. This 7, now look at the row. 7 over here can reach 8, yes. Look up at 8. 4 can look up at 8. 6 can look up at 8, yes. 6 is lower than 8 and 4 is below 6, not blocking. 4 is not blocking 6. Can 5 look up at 8? Yes, but 6 is blocking 5, right? 6 is a little tall, is blocking the view of 5. 6 is not lower than 5. So that's it. These should be my 4 people who can reach. So for 8 can be reached by 4 people in these 4, the ticks. Let me see if it's correct. He can be reached by the individual on his left at height 7, yes. By the 2 individuals at his right at heights of 4 and 6, yes. And the individual about height 5, yes. And now I can be confident. I have understood this clearly. It's okay if you spend this much time. You'll notice that the rest of it is going to be quite simple. Fill up a 4 over here. Then start applying this. And before that, the last sentence, rows in the layout are numbered from top to bottom. Okay, R1 to R5. And columns are numbered from left to right. That's the standard way of doing it. C1 to C5. I'm not writing it down. Let's continue over here. 6 over here can be reached by who? 1 looks up, yes, 2 looks up, and 4 looks up, rest are lower. 3 people here. 3 cannot block by 4. So 3 people so far. And over here 9 is blocking everybody else. So I can just write a 3. Now 1 over here is the shortest person, right? Now for somebody to look at 1, right, to be able to reach 1, should be lower than 1 at 0. Nobody is there. Nobody is there. So for all the 1s, I can actually fill up 0. Nobody can reach 1, right? Nobody can reach 1. Any other 1s over here? No. 2 is interesting. Only 1 can reach. Look at 2. The rest are blocking. That's it. So only 1 person, and that's 1. 4 over here can be reached by 2. Yes. Then 1 gets blocked by 2. Just 2 over here. 3 can look at 4. 2 can look at 4. 1, 2, 3. The rest are blocked by 6 and all of that. So 3 over here. Now what about 3? 4 is too tall, blocking everybody else. 8 is too tall, blocking everybody else. That's a 0 over here. Now what about 9? 9 is very tall, right? So everybody should be able to look, but there shouldn't be anybody blocking. 6 can look. 7 looks, but the rest are blocked. So 6 and 7. 5 looks. 3 and 2 are blocked by 5. And 8 over here can look, right? 6, 7, 5, 8, 4 of them, right? If you're going to be doing on your own, you'll be quick, as I have to tell you as to which ones. It takes a bit of time, right? So 1 over here, rest are blocked. 3 can, and that's it. 1 and 3 only, so that's going to be 2. What about 3 over here? 2 can, and that's it, right? 2. What about 2? There are no 1s over here. Just look up, down, left, right. They're all taller, so that's a 0. 8 over here. 1, 2, 3, 4, 5, and that's it. Moving to 7 over here. 9 blocks, 3 can, 1 is too short, right? Blocked by 3. So just 3 over here, right? Just 1. What about 4? Only 3, right? 3 is blocking 2. Only 3, the rest are taller. So just 1. 6 over here, 1, 2, and 3, and 4, and a 5, and a 6. Oh, that's quite a bit, right? 2 can, 4 can also, yes. 1 can and 3 can also. 5 and 4, yeah. 8 is too tall. What about 5 over here? 8 and 6 are too tall blocking. 2 can view, and that's it, 1. Next up, for 3, just 1 can. 9 over here is very tall. 1, 2, 3, rest are blocked. 4 can, the rest are blocked, right? So just 4 over here. What about 5? 4 can, 1, 2, 4, 1, 2, and that's just the 3 of them. 2 over here can be reached by 1 only, right? Now onto the last row, right? 7, 1, 6, and that's it, right? The rest are going to be blocked. 2, 6 over here, 5 is yes, 3 is yes, rest are blocked. 2. What about 3? 1 can, rest are no blocked, right? Just 1. And 9 is a very tall person. 2, 5, 8, 3, 6, 7. That's a total of 6 over here. Now we can move to answering the questions, and it should be relevant, I mean reasonably straightforward over here, right? So let's just move to the questions. How many individuals in this layout can be reached by just one individual? By only one. I have to just find out the ones over here. 1, the next row has nothing. 2, 3, 4, 5, 6, 7. That's a total of 7. Option 3 over here. Which of the following is true for any individual at a platform of height 1 meter? 1 meter is so short, nobody can reach, no? Okay. They can be reached by at least one individual, at least 4 individuals. Cannot be reached by anyone, right? You don't even need to solve the entire case. This is a question you can take up very quickly. Height 1 meter, we saw at the start itself, it has to be 0, cannot be reached by anyone. For anyone to reach them, has to be lower than 1 meter, has to be 0. That's not possible. Third one, we can find 2 individuals who cannot be reached by anyone in the which row or column. 2 individuals who cannot be reached by anyone, 2 zeros, right? The last row, do I have 2 zeros? No. The fourth row, 2 zeros, no. Fourth column, right? This is the one, fourth column. I have 2 zeros, yes, right? I can find 2 individuals who cannot be reached by anyone. Middle column, just try it out. There are no zeros, right? It's definitely going to be option 3 over here. Next one, which of the following statements is true about this layout? Each row has an individual who can be reached by 5 or more individuals, right? I need to find whichever is true. Do I have 5 or more in the first one? No. False. Each row has an individual who cannot be reached by anyone. Each row has a 0. There is a 0 in the first one, second one, yes, third one, no. No zeros in the third one. Wrong. Each row has at least 2 individuals who can be reached by an equal number of individuals. So in each row, I have 2 people with the same number of people who can reach them. Yes. First one has 2 3s and 2 zeros. Next one has 2 2s, fine. Third one has 2 1s, yes. 3 1s in fact, fine. Fourth one, right, we have 2 1s, fine. Fifth one has 2 2s, yes. Each row has 2 individuals with identical number of individuals who can reach them. So option 3 should be correct. Quickly we can look at option 4 as well. All individuals at height of 9 meters can be reached by at least 5 individuals. Here I have a 9 who can be reached by only 4, right? 5 or more is not happening. So therefore this is also incorrect. Option 3 is the correct answer. Guys, if you like this video, do hit the like button and do subscribe to this channel in case you haven't already, and do visit mockcat.com and get access to a lot of free resources. Take up the daily quizzes which are free every single day. Take up the free mock test. If you want to reach out to us, you can just call us up and let us know, and we'll look to connect with you as well, right? So you all the best. Continue watching the series.